ये हम दोनों वो साथ में आगे जाओ नहीं आप लोग आगे नहीं ये सब कर रहा हूँ ना मुझे लगा कर दो सर ये लाइट देना था वो दिखाई नहीं दो दो लाइट ये टच नहीं करना है गिर जाएगा तो This is one. You're going there, you have to. And you can have a parallel connection. Okay. You will have a parallel.
Good morning, everyone. It's my absolute pleasure to welcome you all to this insightful session on the semiconductor manufacturing industry in India and globally. We are honored to have with us today an eminent personality whose contribution to semiconductor technology and e-governance, digital transformation have left an inevitable mark. Professor Sankara Prasad. Before we begin, let us take a moment to acknowledge the presence of our distinguished faculty members, respected guests, and enthusiastic students, all gathered here to delve into the fascinating world of semiconductor manufacturing. With an MTech from IIT Kanpur and a PhD from State University of New York, Stony Brook, Dr. Prasad has spent over 20 years shaping the semiconductor industry and an additional 2 decades transforming e-governance. Dr. Sankara Prasad is a visionary leader with extensive experience in the computer chip manufacturing industry, having worked with global giants like Intel, Cypress Semiconductor, Robert Box, and CS2 in Belgium. His contribution extends beyond the industry, as he has also been a pioneer in e-governance solutions, integrating technologies like blockchain, AI, and IoT to revolutionize governance and public service delivery. Now, I would like to invite our respected director, sir, to felicitate Professor Dr. Sankara Prasad.
Can you hear me in the back? Won't see that. Why did I lower that?
Now, I would like to invite our respected director, sir, to felicitate Professor Dr. Sankara Prasad. Thank you, sir. To formally inaugurate this session, I now invite our respected director, sir, to deliver the welcome address.
Good morning. Good morning. Very good. You see, my welcome address, I thought that I can introduce the professor. I think still I can do that. Okay. I think, you see, a week ago I was in IIT IIT Guwahati. And then we were just sitting across the dining table and he was mentioning some semiconductor word. I overheard. Then I volunteered and then I went and then I discussed with him and that's how he could come here today and in spite of busy schedule. And though he's basically in Bangalore and he's a professor of eminence at IIT Guwahati to set up semiconductor related technologies. Okay. And I think as he already Senita has introduced Professor, he's a distinguished alumnus of IIT Kanpur. I think many great personalities who used to be advisors to government of India like C.N. Rao, and I think they are all of the same age group, maybe a little younger than that then. And then he did his PhD from State University of New York and Stony Brook, New York. Okay? And then he has been working long years on semiconductors, materials, and more than that. And he worked with 17 countries, and then he worked with Intel, you name any company, and he had some kind of association. And he set up this semiconductor assembly line, and he also has a key role. And then with the Tata's investments in IIT Guwahati, where they are making the semiconductor investments. And then he has come to IIT this Guwahati to see that in the laboratory level and how we can set up a similar kind of facilities. Because I was always talking with you, like when I always go to Japan and Germany, how the undergraduate students get hands-on experience, right? Last time also I was mentioning. And therefore you would like to visualize that in IIT Guwahati. And then now he is a professor of eminence. He is also a visiting professor at University of California, and also is a professor at the Indian Institute of Science, Bangalore, and he has several books. And in recent times, he's more involved in contemporary technologies like artificial intelligence and IoTs, particularly for the rural India. Okay, and he organized. He is a Sankar Prasad is presently the founder and managing trustee of Sampurna Swaraj Foundation. The foundation focuses on implementing frontier information communication technology solutions, Gram Panchayat level, to enable participatory democracy and facilitate accountable and transparent local government. Okay, it is very, very important for the order of the day, because we need to have a transparent local government. Okay, if it is not transparent, you know that all within in the darker side, many things are happening, no, like corruption and other things. I don't want to tell those words because they are all creating the negative energy. We have to be positive. And therefore, he's so kind enough, and he had led so many delegations. For example, the India Afghanistan Innovation Fair, top 3 finalists in NASCOM Social Innovation Award, the winner of Certificate Excellent in ICT Bihar Innovation Forum e-Governance, advisor to MP Anand Kumar's team for the Sansar Adarsa Gram Yojana project, advisor to Namma Bangalore Foundation, member Karnataka IT Task Force for Rural Development, and so on. And there is 3 pages. Okay, he advised me not to read everything, but you should know. And of course, if we can circulate this also, because the purpose of reading a biodata is not to praise the speaker, but you should know who is the speaker and how he could come to travel this path. He was also like a IIT, a BTech boy. That be some 45 years ago, maybe roughly. And now you see, he would like to transform this country digitally, and also he would like to use the contemporary technologies like artificial intelligence, machine learning, and other things to develop rural India, because a growth of a country is not growth of Mumbai, Delhi, or Calcutta, or Chennai. Okay, it should have an inclusive growth. The inclusive growth will happen only when rural India is developed. And I think majority of you here, they are all from rural India, I'm sure. Only maybe the 25% are with a little bit of towns. Otherwise, majority of them from rural India. The development of your development is rural development, right? And you develop, your rural will develop, your community will develop, the country will develop. That is also what his objective also. Such a great professor is with us. We are very fortunate to have such a distinguished professor, and I take this opportunity. I request him to come again and again, stay with us for a couple of weeks, give a series of lectures, and so that not only in IIT, correct IIT Guwahati, we are setting up the semiconductor facilities, but we also would like to have it IIT Manipur. We are more on information communication technology. maybe in the years or in the days to come, I would like to see that all my BTech students who are in electronics and communication should have an hands-on experience. They should know what is a device, what is a material, how the electron is getting transported, how the device is functioning, what is a package, and these kind of things will happen only when you have a facility. Because the countries like Japan and Germany or US, they are not great, but because of the knowledge economy, they created an excellent infrastructure to the youngsters. When excellent infrastructure is created in the educational institutions, these youngsters will create a knowledge economy. You come up with new ideas, new inventions, new devices that will give you a lot of prosperity to the country. Okay. To happen to that, I think rightly the government of India now focusing on the semiconductor and artificial intelligence, which is the order of the day, which is going to be the future of the world. Okay, and therefore, if you get a chance to work in the clean room to make a device, if you understand what is a device, definitely our children. I know that I have been to 32 countries. Suppose our professor also traveled widely. Our children are much more intellectual. IQ level is very high. Our thinking is very high because we are all majority of our children are come from rural background. Because in rural background, you mostly live with the nature. You always ask questions. You see why the green leaf is green and why people don't sleep under the tree at the night. You understand that it gives carbon dioxide, right? But why you want to relax in the daytime under the tree? It gives a very pleasant oxygen, right? See, this is how you learn there by experiencing and traveling along with the nature, right? The same way, if you travel your academic activities with expertise, with infrastructure, where you keep your hands-on experience, definitely you all can come up with innovation, and we can make this country as a knowledge-driven economy. Okay, so knowledge-driven economy is very important for the prosperity of the country. Okay, the knowledge can make Atmanirbhar. The knowledge can only make the make in India. How can you make in India? You have to create infrastructure. You have to create machineries. You have to create assembly lines. You can create opportunities. You should not rely on imports. Many times we buy a lot of expensive equipments all over the world. After 6 months, even if one resistor broken, they say that you change completely the board. You have to spend into lakhs of rupees. Spending a lakhs of rupees is also not a problem, but you have to wait for months together to get it shipped and come to your place by spending crores of rupees on the machine. Therefore, that will not happen in the coming years. I am very optimistic, sir. Whenever I interact, the kind of enthusiasm our children are having, and I think this is a small testament of the entire young population in the country who are in the age of 20 to 29. I think they are going to make a great Viksit Bharat, and I congratulate all of you. Let us have a big hand to every one of you. And also, I would like to request all of you give one more very big hand to welcome our professor. Thank you so much, sir, once again. Now the platform is yours, and feel free. Yeah, thank you so much.
Thank you. Can you hear me? Yes, sir. Thank you very much, Professor Krishnan, Oscar, for giving me an opportunity to see a different India. Because I come from Bangalore, never had an opportunity to come to Northeast. So it's a great invitation from you, and it's so nice to see a dynamic director like this. And he's marketing Manipur more than Manipur Chief Minister, I think. So I'm going to recommend his name to the Chief Minister to make him the Tourism Minister of Manipur. So he already took me to all the temples and the fort, Kanga Fort,
Emma Market.
Yeah, Emma Market. So We had a very, so I'm going to move to Manipur, by the way. If he gives me a job, I'm coming back here. So that's thank you very much for the invitation. I have probably about an hour, I think, or something like that. So before I start this talk, I wanted to have a feeling because I think all of you are electronics and communication. Is that correct?
Yes, sir.
Okay. And obviously, all of you are learning how to design a PLSI chip. Is that correct? I see high levels. I see silence. Okay. How many of you have designed or trying to design a VLSI chip? Raise your hand. Nobody yet.
No, somebody has raised.
Somebody. Okay. The reason I'm asking this question is, most of us use mobile phone, laptop, electric vehicles, space, defense, everywhere. What we see is a computer chip today. Okay. So that is how many of you have seen a PC board with multiple chips on it? Please raise your hand. Okay. So all of you have seen a PC board with computer chips on it. So you know what a microprocessor is, you know what a grid chip is, or a graphic chip is, etc., etc. So this technology started almost about 50 years ago. One of the original companies was Intel, and then of course IBM, AMD. Now of course, I'm sure all of you have heard about NVIDIA. Yeah. So this is the technology that has grown from, I would say, from late 1960s, 70s, and then today it is the hottest topic. I'm going to ask you one more question. How many of you have actually seen a wafer, a silicon wafer? Okay. The reason I ask this question is because it's very important for you to understand that is before you see a chip on a PC board, that chip is manufactured on a huge wafer. It's called a silicon wafer. And it goes through about 700 processes before a silicon chip gets formed. So there are multiple processes like photolithography, ion implantation, diffusion, etc. etc. Nagesh, are they studying any of these things here?
Yes, sir.
Then you have
Semiconductor device.
So you understand semiconductor device. Now, today, to set up a wafer fab, India doesn't have a wafer fab even today. Just so that you know, okay? India does not have a wafer fab. There is one wafer fab in Chandigarh, which is about 50 years old. Okay? Because to set up a wafer fab, a simple wafer fab, it costs about $15 billion. That means 1,20,000 crores to set up one factory. And Tata is setting it up for the first time in India in Gujarat. Okay? And that too, it is called a 28 nanometer technology. Okay? And those of you who know a little bit about nanometers, etc., it's a 28 nanometer technology. Taiwan has the best technology, which is 2 nanometer technology. Okay? So this 2 nanometer technology, if you want to set up a factory for 2 nanometer technology, it costs 4 lakh crores. Do you understand now? And that is the budget of our country to support Anna Bhagya for all the villages. That means we support 6 lakh villages by giving free rice, and that costs 4 lakh crores. Imagine if I spend to build one factory, that means all the villages will have no rice. Okay, that gives you, I want you to understand the magnitude of what it takes to set up a technology in a country. Okay?
Yeah, there's some why is the
If you want, I can transfer the thing.
it will come out. Because these are better, still more visible also. Hey, it's coming, wait.
I think you should stand there.
It's taking little time.
Yeah, that's okay. Right. So, as I said, our country cannot afford today to spend like 1,20,000 crores or 4 lakh crores to set up what we call a wafer fab. So the next technology that we look at is, in order to be in the global scenario, because semiconductors are absolutely important today, because every device every instrument that we use has some kind of semiconductor chip, whether it's a graphics chip or a microprocessor, a controller, or a memory, etc. Okay? So from that perspective, we are looking at a technology called semiconductor packaging technology. That means after the wafer is fabricated with chips, okay, we take that chip and put it into packages. So what you see on a PCB is multiple types of package technology. And that also is an extremely important technology. All right? Because how many of you know what a MEMS is? Yeah. Other than Professor Nagesh. I mean, if you respect Nagesh, of course. Now, the reason I asked this question, MEMS or microelectromechanical devices. Similarly, we have optical sensors, different varieties of sensors. And we have to integrate all these guys. For example, when you have a mobile, it has not only microcontrollers and memory chips, it has lots of sensors. Optical sensors, IR sensor, temperature sensor, all kinds of stuff, or what we call accelerometer, and so on and so forth. Okay, varieties of sensors. So you see, in one simple mobile phone, I have probably 50 varieties of computer chips. And that has to be packaged in a very, very small mobile. All right? So this is the advanced packaging technology. And this, I think, is where India should go. Because we cannot spend lakhs of crores, but we can certainly spend thousands of crores. Okay? So the reason I'm talking about this particular technology is, you will see here, I was in Assam. I have been in Assam for the last few months. Tata Semiconductors has established a factory for 27,000 crores. Okay, it's a huge factory they're building near Guwahati. So that is going to be what we call semiconductor assembly and packaging factory. And this is the technology that I think those of you who don't know today must get into. Because there are lots of VLSI designers in our country. Okay, otherwise many of you who do VLSI design become software engineers and go over for data analytics. Okay, so very important for you to understand is now the market is open. The market is open, the technology is open. So I thought I will introduce you to this kind of technology today, so that you know that this is the future of India and this is the future of the world. How advanced packaging technology is done, whether it's NVIDIA, AMD, Intel, etc. So I'll give you a brief background as to what is happening in this technology background, and if you have any questions later, please feel free. Okay. So as you can see here, so approximately it will create about 2 lakh jobs across the country, and probably 3 lakh indirect jobs. So that means we would like to bring the jobs to the Northeast, because most of the people who get graduated in the Northeast, whether it's Assam or Manipur, many of you end up in Bangalore or Pune or Hyderabad. So it would be nice if all of you stay back here and work and make Northeast India a very dynamic center for India. So that's the only reason. Oh. So this is the semiconductor growth pattern, and you will see here mobiles, smartphones, high-performance computers, autonomous vehicles, self-driving cars, IoT devices, big data, etc. All these areas where semiconductor chips are used, and because the main technology drivers, whether it's artificial intelligence or 5G, is the speed of the semiconductor is going way higher. Okay, we all want high speed. Interconnect density is going way higher. That means we are putting a lot of chips in one small device. Pad pitch, that means everything is getting small. Okay, when you have a 2 nanometer device, the pitch is getting very, very tiny. I'll tell you what that means. And the chip size is getting very large because I'm attaching billions of transistors in one chip. So the chip will get very large. And of course, when I put so many devices on one chip, the power gets very high. So thermal management. Most of you know what thermal management is. Yeah, okay. So you have to worry about heat dissipation. Otherwise, in your mobile, you'll be burning your hand. Imagine. Okay. Because I still remember when the first laptop was designed by IBM, that was 1984, 1985. So they did not know how to dissipate the heat. So when you put the laptop on your lab, it would burn your lamp. Okay, because they did not know how to dissipate the heat. That is when you see all the fans and everything. Correct? So these are all the extremely important technologies. So when you have to worry about thermal management, you have to worry about what we call computational fluid dynamics, okay, heat dissipation, different kinds of materials that you have to use, right? So these are the issues that one has to study. So for example, in IoT robotic, we have multiple varieties of department. Okay, so that means if I ask you which is the best heat conductor in order to dissipate heat, what would be your answer? Anybody knows? Which is the best heat conductor to use to dissipate heat? Copper is one, okay. Silver, gold, very good. Anything else? Sorry? I could hear it. Anyway,
Platinum. They say platinum.
no, okay. Good. At least most of you know. Most of you know the periodic table. That's good. So they all come under the same periodic table. You know that. Copper, silver, gold, platinum, they all come. But the best heat conductor is diamond.
Diamond.
But the diamond is the most expensive thing also. Now, can I use diamond as a heat conductor for a very cheap? Your mobile will cost you 1 lakh rupees instead of 6,000 rupees. Okay? So these are the things that we look at when we design advanced packaging. Okay? It's not just the electrical performance should be perfect, but all other, it should be lightweight. I say gold density, many of you probably still remember your gold chemistry and physics. Gold density is 90. Diamond density is 3. Okay, so the copper density is 9. So obviously, diamond is 1/6 the weight of gold, and the conductivity is 3 times that of gold. I would love to use diamond, but I don't think anybody would approve that I use diamond as a heat conductor. Okay, so these are significant challenges that we find, particularly in packaging technology. Particularly if I want to send something to space, it cannot be heavy. Okay, it has to be extremely light and it has to have long durability. So when we design packaging for space, it's very different from when I design a packaging for a Christmas card. When I open a Christmas card, it has to sing only jingle bell, jingle bell once. Correct? After that, or happy birthday once, and then I go throw it away. It's the same chip I use in space, where it has to work for 20 years. Same chip, depending on whether the application is a Christmas card or a birthday card versus whether it's space, variety of packaging technology. Whether I use it in an airbag system in a car or a brake system in a car. Okay, I cannot afford to have failure of a brake system in a car. Correct? Can you? Can, right? So these are the issues that we look at in advanced packaging. So I thought I'll expose you to this area, and I want all of you, 150 of you, to get into this domain eventually, so that you know that this is the future of semiconductor technology. So these are the advanced semiconductor. It needs critical infrastructure backbone in order to make this work. It's a critical national goal, according to us, for India. It's called the ISM, that's the India Semiconductor Mission, and there are about 10 factories. Tata's is building a 27,000 crore factory. There are other 7 companies that are building 10,000 crore, 15,000 crore, multiple factories in this domain, in Gujarat, Hyderabad, Karnataka, etc., etc. So there's a, sorry. There is a rising global demand for packaging and testing, and of course, what we look at is 3D packaging. What you see on PCB is 2D packaging. It's all next to each other. Okay, so we are now looking at 2.5D or 3D packaging. I'll expose you to that concept also a little bit. And of course, bridging multiple skills. I just don't want a VLSI designer. I just don't want an electronics guy. I want somebody who understands mechanical, what I said, heat dissipation technology, computational fluid dynamics technology, material science, artificial intelligence, and so on and so forth. So we are looking at varieties of technology that one can use in order to be in this business. And of course, very important is strategic collaboration between academia, industry, and the market. So, those of you, have you heard of, how many of you know who is Gordon Moore? Please raise your hand. Anybody knows Gordon Moore?
Moore's law.
Yeah, do you know what is Moore's theory? Very good. Correct. Number of transistors doubles every year. Okay, but this started 50 years ago. So we cannot go anymore because we have already reached less than 1 nanometer. So that is why most of you who read recent news by Satya Nadella, he has designed a quantum computer. I'm sure many of you must have read that, right? So, but that is way out. It's not possible for us to do it today. But the thing is, if we are going to go into Moore's theory, so in India, today we are working at about 25 nanometer. That if Tata sets up a system, it will be a 25 nanometer technology. Today we are in Chandigarh, we are at 180 nanometer technology. Whereas Taiwan is at 2 nanometer technology. So you can see now how the CMOS technology is going down, and it's a very, very long way before we ever be able to come into this level. All right. So we look at how do I integrate the analogs, the RF, the passives, HV, sensors and actuators, and biochips all on a system. Everything should be on one system, and this is the future of packaging technology, where I can integrate everything in one system, and that's what I'm going to talk about. So this is how evolution of packaging happened. Once upon a time, 1980, I started working in 1981. Okay, probably half of you were not even conceived or thought about it. So, except for probably the director, maybe Nagesh, I'm not sure. Okay. No, you're not born. I see. He also not even born. Alright. So that gives you an idea how things happen. Alright. So just so that you know, since some of you know Gordon Moore, when I started working for Intel, Gordon Moore was in the same office block as I was. Okay. Gordon Moore, Andy Grove, and Bob Knox. These are the three people who started Intel. Okay. And believe it or not, I was a tennis partner for Andy Grove. Andy Grove, most of you know, was the chairman of Intel. Okay. So just to give you an idea how history has come a long way. All right. So this is important for you to understand how history has come through. And this is what we used to do once upon a time. Okay. Then of course, system in package, RF module. This is called 2.5D IC, silicon imposers, embedded bridges, high density. Then we talk about 3D chip on a wafer, and then this is the latest one. It's called heterogeneous integration. Okay, that means multiple varieties of chips on one substrate, and the substrate is not anymore. PCB is a polymer substrate. I'm sure most of you have seen polymers. We cannot afford to have polymer substrates anymore because the signal integrity, the speed of signals, everything has to change. So new technology has come in, what we call glass substrate. Okay, where you connect multi-layers of glass with holes in between, and that is called heterogeneous integration. And where we have photonics embedded along with the electronics. Okay. And there are two varieties. One is chiplets for harsh environment and chiplets for benign environment. That means if I have a controller inside an aeroplane or inside a car, it's called a benign environment. If I have it under the hood, that means near the engine in the car, it's called a harsh environment. Because there I have moisture, dust, high temperature, all this. So whenever we look at packaging technology, we have to worry about that. If I am sending a package to space, I have to worry about radiation. There are varieties of radiation. Okay, cosmic radiation, neutrino radiation, etc. So we need to worry about how the materials behave in those spaces. Okay? So those of you, and as you know, the next frontier for India is space. Everybody is going to space. So we need to worry about electronics or heterogeneous integration for space technology. So this gives you an idea. As I said, in the heterogeneous integration, we look at, for example, a CPU can be a 5 nanometer CPU. This can be a 90 nanometer and this could be a 7 nanometer. So varieties of chips can be integrated onto one substrate, and that is what we look at in a packaged. So here is a memory stack, here is the CPU 1, CPU 2, GPU 1 and GPU 2. All these things are integrated under one substrate, and that is what SoC is. And the reason is, I don't know how many of you know, it takes about 2 to 3 years to design a chip and get it manufactured before it comes to the industry. So it will be better if I already have varieties of chips, I take it and integrate it. So that is the correct way, and that's for time to market. That is, the market needs something, I should be able to ready to deliver. Okay? So these are the issues that we look at, but from all these issues. So this is where we come into 2D and 3D packaging. Here is the silicon chips 50 to 100 micron thick. Anybody know what is the diameter of your hair? Anybody knows? How many microns? Or how many millimeters? No, the reason I ask this question is you should have a feel for dimension.
Yeah.
If you don't have a feel for dimension, you are bullshitting. Correct.
I told me in my lecture also, right?
How many of you know what's the diameter of your hair? Yeah, sorry, Nagesh. You have to keep silent. I just want these guys to think a little bit. Yeah, okay, I'm going to look at somebody. Get somebody. Yeah. What do you want? Take a guess. Brown jacket. Yes, sir. 10 microns. Okay. Anybody else? Now it's an option. You can bid higher or lower.
Tell.
Okay, but double. Anybody else? Okay. Just to give you an idea, it is 75 microns. One hair, approximately. Okay. A hair is about 75 microns. Okay. So that gives you an idea. All right. What is the hair? Now, when I make my silicon chip, it is less than 25 microns. You understand the chip? That means, when you hold the hair, will it stay stable? It will bend, right? Because the hair is very thin. So imagine I got a large chip, which is 1/3 the diameter, 1/3 the thickness of your hair. Okay? So this is the kind of technology that has to be handled in manufacturing. At extremely high speed. Because I manufacture approximately 1 million chips per hour. Okay, so this is the technology that Tatas are building into Assam. Okay, we manufacture approximately 1 million chips a day, or about 48 million chips a month. So you can imagine what it takes to high-speed manufacture that kind of chips. So the reason I'm bringing all this is you must have the feel for it. I think I'm sorry. I came straight from Guwahati. If I had come from Bangalore, I would have brought a suitcase of mine and I showed them what a wafer looks like, what a varieties of package looks like, what a space package looks like, etc. Because unless they have to feel, it's very difficult to imagine. That's the reason. So someday, next time when you invite me, I will certainly be very happy to bring the suitcase. So that people have to have that experience of looking at and feeling what it happens, how it happens. So we look at substrate thickness, and substrate thickness is 100 microns. That means it's a little bit thicker than your hair. So these are things that we look at. And 1990s it used to be like this. In 21st century, we have 3D packaging. So we are stacking a 25 micron chip, one on top of the other, 16 of them. How many of you know? How many of you have a Western Digital SD card? I'm sure most of you have SD cards, right? Those are all SD cards. Those SD cards are Western Digital. And each that chip is 25 micron thick. And they have 16 of them, one on top of the other. Okay, you understand? So the total thickness is 0.6 mm. And your SD card is 1.2 mm. Okay, I'm sure most of you have seen the SD card, right? Its SD card thickness is 1.2 mm. Inside, and that's got a plastic cover on it. Inside that there are 16 chips that are one top of the other. Imagine producing that. Okay, so this is the technology. That's the reason I'm giving you a real life feel for what it is to go into this technology. So that is what 3D packaging will all be in the near future. And India has to come into this technology very soon. And all of you should go towards that. So major challenges, of course, as I said before, it is highly multidisciplinary field and it needs to impart skills from fundamentals. Okay, that means you must know. Just now you said copper, silver, platinum. Yeah, if I ask you why copper is a less conductor than silver, or gold is a better conductor than copper, do you know whether gold is a better conductor or copper is a better conductor? You think so? Think a little bit. Okay? The reason I'm bringing all these issues is very important to understand at the fundamental level. Alright? So it's not necessarily just how to design using cadence or synopsis. That is only software. The hardware is understanding why I use aluminum metallization, why use silicon nitride passivation, why do I use gold wire, why do I use copper wire, etc., etc. You must have the feel for why do you use different materials. So that's the reason I'm bringing this. An important mandate, that's why I wrote this for IIT Guwahati, is to produce technically skilled manpower for Indian semiconductor with a focus on Northeast states. So I think Northeast has fantastic capabilities now with IIT, IIT Guwahati, etc., etc. So if somehow we can all make it all work together, it would be fantastic to bring Northeast competency to a higher level. So this is just we were trying to set up what we call Center of Excellence in IIT Guwahati to support this huge advanced packaging technology. And of course, that will be 3D packaging. Of course, we'll use artificial intelligence, deep learning, and all that stuff. Manpower training, industry collaboration. Of course, we want to strategically support national missions, whether it is space or healthcare, development of packaging infrastructure, and promoting national as well as regional growth. And these are all though I don't know how many of you have worked with gallium nitride, gallium arsenide. Okay, these are all the multiple technologies that one needs to know. The silicon is not the only chip. There are varieties of opto chips, silicon carbide chips, gallium nitride, etc., etc. These are all the technologies one has to understand to integrate it into the advanced packaging. Multi-chip architecture. Earlier, if you open your i5 or i7 computer, you will see one chip like this. This is called a monolithic die. A chip is called a die in semiconductor language. Okay, so this is it's a monolithic die. Now we are looking at multi-die. MCM means multi-chip module. The next technology is what called chiplets. Okay? Chiplet is the next technology. So I want all of you, including Dr. Nagesh, to train people in chiplet technology. Okay? So start thinking chiplet right now. Forget about individual die design or chip design. Because this way, they are already ready to think like that. Because this is the way the global market is going, and this is the way India should go. That's the only reason I brought this up. So please think about how to set up, how to think. And chiplets will be the key enabler for the next 10 to 20 years. And how many of you know what you know TSMC? Yeah? Okay. So TSMC, a small country like Taiwan, with less than 10 million people, controls the semiconductor industry of the whole world. You know that. I'm sure all of you read newspapers. And main reason America and China are fighting is because of Taiwan. Okay? So imagine, according to Taiwan, chiplet is the next frontier of technology, not large single chip tags. So I want every one of you have to start thinking chiplet, how to design a chiplet, how to manufacture a chiplet, and so on and so forth. So I thought I will bring this issue. So I have about 10-15 minutes. I will just run through this. So I will not go into the details of it. So there are many. So basically, what are the drivers for chiplet adoption? Okay, very important is Smaller dies give higher yield. What I mean by that is, how many have eaten a pizza, large pizza? I'm sure all of you, right? What's the diameter of pizza? You know? Louder, louder. 20 inches? No. 9-inch is a small pizza, 12-inch is the large pizza. Okay. Of course, if you go to America, you get the super large one, which is probably 24 inches. That's a different story. Okay. So usually 12 inches. Okay. So each wafer that we manufacture in the industry today is 12-inch wafer. That means it looks like a pizza. Millimeter. And the thickness of that guy is 1/3. What's the thickness of pizza? How many? Don't say it in microns. It's obviously not microns. Correct. It's about 1 centimeter. Correct. 1.5 centimeters. That means 15 millimeters. And 1 millimeter is 1000 microns. Correct. 1 millimeter is 1000 microns. All right. Now you know, if I give you a pizza that is 1 millimeter thick, can you hold it? It will also soggy now, right? I mean, it will just even the 1 centimeter one, you cannot hold it by hand. By the time you hold one slice, it's already fallen. Correct? You cannot even eat it. Now imagine this 12-inch pizza wafer is 1/3 the diameter of your hair. Okay? Imagine that. It's large, extremely thin. We have to handle that. Alright? So, see, when you make a microprocessor is approximately 1 centimeter by 1 centimeter. Okay? That's the general size of a microprocessor. About half a centimeter by half a centimeter is a memory chip. Okay? But if you take any other watch chip and all that, that is less than 1 millimeter by 1 millimeter. You understand now? So, the chip size, so on the same 12-inch wafer, if I have a 1 millimeter by 1 millimeter chip, I can have literally 100,000 chips because it's a tiny chip, and on one wafer I can accomplish a lot. Whereas if I have a microprocessor chip, which is 1 centimeter by 1 centimeter, then I have only probably 2,000 chips. Okay. So obviously, when I go through this whole process of manufacturing a wafer, I would rather have small chips because that my yield per wafer is very high. Okay. So this is how we look at designing a chip. That's one of the major reasons we went from 25 nanometer to 2 nanometers, because I can have maximum number of transistors on an extremely small scale. Okay. So when we look at that, so this is called yield. That means for the same. Hi, am I boring you guys in the back? Okay. Because there's a noise, people in the front can't hear. Thanks. Okay. So basically what we look at is, how do I create extremely small dies so that on a large 12-inch wafer, I get maximum number of chips. Okay. So that is the whole idea of creating chiplets. So this is how we look at chiplets. Can be when you go into the industry, you will see there is something called binning. That is depending on the speed of the chip when you test. You bin it as bin 1, bin 2, bin 3. We look at all that one. Okay. So how do we define chiplet? A chiplet is an integrated circuit block specifically designed to work with other chiplets to form a large, more complex system. And it's what we call reusable IP blocks. So this is the one we do. I will not go into the detail. It differs from a system, silicon SiP or traditional multi-chip module. Chiplet is not a package, it's a design philosophy. That means when I design the complete solution, let us say you want to design a complete PCB for handling the ignition system of a car. So that means you need microcontroller, you need a temperature sensor, you need something else, something else, something else. All that you have to think from the beginning so that you design the chip so that they operate with each other. Okay, so this is how we look at chiplet design as the future of 21st century's solution design.
What is the chiplet package? As I told you already, Xilinx is doing something wired. Okay, so these are all the organic substrate can be used. Silicon interposer is used. This is what we call a fan-out technology or a fan-in technology. I will not go into the detail of all that. And 3D configurations with micro bumps. Most of you must have seen a PCB. PCB has holes, and you put a thing there, right? Soldering, correct? But that has only about 16 or 24 or 48 pins. But today, we make chips or chiplets with probably 4,000 leads. So that means I cannot have 4,000 holes on a PCB. So we have what called micro bumps, and that's called flip chip technology. Okay, so these are the kinds of technologies that are being developed in order to accommodate large number of chips on one single substrate. So this is that's how we look at what is the micro bump technology. Then of course, most of you know AMD, okay, just like Intel, AMD also. So AMD has this technology, and they have approximately 8 CPU chiplets that are already working in organic interposer. Okay. And then of course, TSMC has this technology called interposer. So here the thing, you see that
We go and see.
this is a chip 1, chip 2, and there are multi layers in which, and you can see here, the line width earlier was 15 microns, and here the line width is 2 microns. So you can see how thin the interconnection lines are, how thin the substrate has to be, and all this is extremely important. And IBM, TSMC. This is Amcor is a Korean company. ASE is a Taiwan company. You see where these two countries are so far ahead, and we are approximately 30 years behind. I want all of you to recognize that. We are approximately 30 years behind. Okay, and we are a large country, 1.4 billion people. Okay, and we have more IITs, more triple IITs than anybody else. But we have to, that's why I call it, we cannot go slow anymore. So ours should be what we call leapfrog technology. That is, we have to jump. See, I'm sure Professor Bhaskar knows, in our days we did not even have a telephone. Let me tell you, we did not have telephone. At least in the last 5 years, all of you have a smartphone. So we leapfrog from no telephone to smartphone. Okay, that means it was possible. So we have to think about how do I leapfrog, not go slow anymore, to this kind of heterogeneous technology, chiplet technology. And that's where I think all young minds in IIT, triple IIT, anywhere for that matter, have to put your brains together to get there. So these are what we call the micro bump technology, Intel's multi-die interconnect bridge. You can see multiple layers. Each of them are connected through extremely thin vias, and the vias are filled with copper, gold, platinum, or diamond, depending on the situation. And that is how the things are built. Of course, those of you who are electronic people, you will understand they are stacked 3D. All right, they have reduced voltage drop, power efficiency is very good, power delivery to the CPU is very good, elimination of passives. So there are no more resistors and capacitors that are put, they are inbuilt into the substrate. Those of you who understand capacitors and resistance, and there are what we call silicon interposers, and there's a 10 nanometer CPU, 28 nanometer silicon interposer. So everything we talk now in nanometers, not even in microns. So this is the idea. All right, and this is another Intel chip. As you can see, this is a package structure. You see how the DRAM dies are stacked on top of each other, and they're connected in between each other through what we call vias. Those are holes in the silicon, and they are filled and then they are connected. So this is the base die. These are the bumps or the micro bumps that I talked about, and these are the package balls that get attached to the circuit board. The circuit board can be a PCB. Generally, it is no more PCB. It is glass substrate or polymer substrate, polyimide substrate and so on. Of course, this is a new technology called hybrid bonding. I don't want to detail. This is TSMC's technology. I just thought I'll show you varieties, what other people are doing, so you get inspired by what other countries are doing. And this again uses silicon interposer. You see here, 12 high chips with a total height of 600 microns. That means each chip is about 40 microns. Because you have to attach the chip, that means there is a layer of epoxy in between. Okay, so I got 25 micron chip, there is a die attach layer, then you attach it, then you attach it and attach it. One and a half. Okay, yeah, high-rise building. Okay, so we are looking next thing that, as I said, Western Digital is already doing 16 chip high elevated building. The very important is this is called the die size growth. As you increase the CPU or the GPU, okay, the number of transistors, in order to get high speed, you want all the transistors on one chip. That is the only way you get extremely high speed. And that's how the chip becomes bigger and bigger, though you go towards the 2 nanometer or 3 nanometer technology. And this is the trend. So the performance requires more transistors, but industry needs a more economical approach. Because as the die size becomes bigger, the yield of the 12-inch pizza becomes smaller. Okay. So in a pizza, if you take a 12-inch pizza, how many slices can we cut? 8, usually, right? If you have 6, then you 5. 8 means everybody gets 2 each. Okay, this is correct. These are the things that happen. So that means there's a particular size of the pizza. Imagine if I have 200 people and one 12-inch pizza. Obviously, everybody has to be cut into smaller and smaller sizes so that everybody gets a piece. If I got 2,000 people and I got a 12-inch pizza, I have to cut it smaller. If I got 20,000 people and a 12-inch pizza, the chip size gets smaller. You got it now? So that gives an idea how we look at on one single wafer. If I have to feed 20,000, if I want 20,000 chips, I need smaller and smaller dies. Okay, so all of you are going to be chip designer. You have to think like that. How do I design the smallest chip with the best performance, with the highest number of transistors? Okay, so this is the way we look at technology. This again, you can see here what's a 2.5D technology, 3D technology, and system on IC technology. I will not go into detail. Power efficiency becomes extremely important. That is where we worry about. And this is a AMD chiplet that looks like this. This is the prototype. For gaming, we use this kind of technology, and it's got copper hybrid bonding. And we are at the beginning of our journey. Okay, this was 2020, and you can see the growth in 2025. We need approximately 600 million packages in this format. So this is where the global requirement is.
Thank you, sir, for your insightful lecture. Now we are going to have a guest lecture on the topic Frontier Technologies for Achieving Sustainable Development in Rural India for CSE students.
No, not now.
I request all the EC students to leave from the left side.
Yeah, one question and if there is questions.
Yeah. Is there any questions that anyone
You
wants
give
to
her
ask?
a job in change doing that.
Anyone want to ask questions?
Yeah, please.
My.
No, I can hear you.
Hello, sir.
Yeah, louder.
Hello, sir. Abhinav from EC department first year. Sir, I wanted to ask, sir, from vacuum tubes, we developed 2 transistors, our computing power increase. Now, sir, there is also limit in this computing, and we are going forward for the quantum computing. Sir, according to you, where is India right now for this quantum technology, and after how much years we can have it in a market level in hands of people, a quantum computing?
Quantum computing, I don't think I will be there. Meaning, sorry. No, if I live, because I told somebody I want to live to 150 years. Okay, I'm only half the age right now. So, yeah, quantum computing will happen. But before that, see, this is what I was telling the other people yesterday. There was an advantage of sound conference. I'm sure most of you must have seen. Before you jump into the ocean and swim, you should know how to jump in a swimming pool and swim. Okay? We don't even know how to jump into a swimming pool and swim. Because that we have been left behind so long ago. Okay? So first thing is to learn how to do electronic work, silicon wafer fabrication, how to design heterogeneous integration, packaging, etc., before we talk about quantum computing. Quantum computing is not a, it is still in the lab. Yeah, I'm sure those of you must have watched either Google guys or the Satya Nadella guys. Correct? You must think that it will be there tomorrow. It will not be there tomorrow. Okay? That's only in the laboratory right now. I would say at least 10 more years before it actually gets into production level technology. Does it answer your question?
We are introducing a minor on quantum computing from next term.
I see.
Along with the electronic, they study one minor program on it, so that they prepare for 10 years.
Yeah, see the problem, I mean, with due respect to Professor Bhaskar, we have been teaching electronics and IC design for 35 years. Please understand, 35 years, correct? But we still don't have one factory. Okay, so all our teaching has been extremely academic, and we support only companies like Intel and IBM by designing part of their chip. Correct? We don't even design a complete chip in our country. Correct? So we have 1.5 lakh VLSI designers in our country. Not a single product. All of them work for outside. Okay? So this is something that is very important. So if we are going to develop engineers, they should be able to develop products and solutions for India, not work for outside countries. So that's the only reason. The mindset has to change now. Teaching is one thing, but delivering an outcome is extremely important. Yes, sir.
Hi, sir, Pratik here. So, I wanted to ask questions related to the semiconductor as well as the artificial intelligence that has been evolved. So, we have seen a major shift in the artificial intelligence after 2018 since the transformer architecture that Google has published a landmark paper, the attention is already. So, after that, the artificial intelligence industry drastically changed, the chat models arrived and all the things happened. But India is not able to capture all the AI still now. So how do you see the need of semiconductors and the computing technology? Is it the reason that India has not catch up the AI trend?
Thank you. See, AI has got nothing to do with semiconductors. Okay, I'm sure you know Chinese developed the DeepSeek. I'm sure all of us know about that, right? So there's a huge group in India, led by IIT Kanpur and others, who are seriously looking at creating our own DeepSeek, if you want to put it that way. Of course, it needs large GPUs. India doesn't have the capability to develop GPUs. We have to buy it from NVIDIA. It will cost millions of dollars. Okay, but even if I give millions of dollars and give you 200 GPUs, we don't have the algorithmic capability to develop the chat GPT or the DeepSeek. So that's what we are looking at right now. So those are two different, let's say, tracks. All right. So you need the AI algorithm development capability as well as the hardware, the GPU hardware.
So India is lacking in terms of both technology as well as infrastructure and knowledge.
Yeah, in fact, correct. Both of them understand. Both of them have to go hand in hand. And with due respect, all of us Indians should also learn to use Indian developed product. Correct? We prefer ChatGPT or Gemini, correct? Rather than if somebody develops it, because you know when Twitter was banned, India came up with something called Cocoa. What is it? They came up with a equivalent. I forget the name. Nobody used it. You see, when you develop something, that has to be used by people. So that means the accessibility, marketing capability, those are extremely important. So it goes hand in hand. It's a technology, people, and progress that has to happen simultaneously.
So will India be able to catch up the AI trend or regarding? So how do we quantify so computing power is necessary in order to catch up with the AI. So as of now in 21st century, everyone is running behind. All companies are running behind AI. Nvidia has launched some CPU. Now recently, the Microsoft has launched its quantum computer, and Google is also working in it. So is India doing any such significant work in semiconductors or any computing technology that will further enable?
I don't think India today has the semiconductor technology that can compete with everything. Nobody can compete with NVIDIA. You understand? No, not even Intel and the IBMs. Nobody has the competency to compete with NVIDIA. All right. So from that perspective, we cannot catch up. All right. So we can only beg and plead NVIDIA, please give me. Okay. I'm sorry. That's that it's not easy. They will not sell it to you because there are lots of restrictions for selling GPUs from America to India or to China for that matter. So it's not easy. There's a lot of geopolitical things that happen. Okay? So it will be some time. But we should stop playing this catch-up game. Alright, very important is we should stop this catch-up game. That is where we have to think differently. We do not hit the wall each time the same way. We should see how we can go around the wall and come up with better ideas, ingenious ideas. Okay?
So yeah. Actually, this AI and semiconductor design found in place for neuromorphic architecture or neuromorphic chip design. So where we try to use brain-like computation in a semiconductor chip. And I mainly work on that algorithmic and signal processing part of the neuromorphic design. And Intel is like looking at Lohi, IBM Spinnaker, these are all neuromorphic chips. So according to you, what is the future of this neuromorphic chip? Are they going to be a game changer for semiconductor chip design?
No idea. You should teach me. Honestly, see, things are so many things that are happening. No clue.
Okay.
So I'll certainly sit with you and learn. But I'll be very happy.
Anyone has any more questions?
Yeah, thank you so much, sir. My question is a little different. Like, for example, yes, Tata is investing and others are investing. But my question is, what about the skilled manpower? If you look at in the colleges or the labs, we don't have any setup to train the students or somebody to meet the needs of the industry.
Correct.
So how we are going to fulfill the gap and train our generation? Are we going to get the manpower from outside, or how we are going to do it?
Oh, that's why he has come here.
Yeah,
Yes, good question. Good that you asked that question. So you can see here, we are trying to set up, I don't know whether we can read, it is a National Center of Excellence for Workforce Development. Okay, very important is we need 20,000 to 20,000 people in the next 2-3 years. So I'm developing a new technology with IIT, okay, where we want to use virtual reality, navigated learning technology, etc., to train Northeast people, Assam, Mizoram, Manipur, etc., to actually go and help Assam or the TSAT plan. Otherwise, you cannot import people from Bangalore or Malaysia. You understand? So this is very, very important, and this is the proposal that we have submitted. I hope I succeed. So if this happens, all of you can come to Guwahati and work with me. So, or work with TSAT. So this is exactly what we are developing. new technology called navigated learning technology, where we are using domain-specific LLMs we are developing, as well as I'm going to speak about the technology next. Because we have implemented the technology called navigated learning technology in the villages of India, by the way, how to train villagers. So I'm going to talk about that in the next session, because that will be interesting to computer science people, I think. Okay. So certainly, if you want, you can stay here and we will talk about this, and you can ask the same question. But yeah, this is the next project that's extremely important for India. How to train 20, 30,000 people to get ready for this manufacturing of semiconductor technology.
I think
Thank you, sir, for clearing the queries. Now I request all the EC students to exit from the left side, and we'll be taking a short break. After that, we'll continue the CSE guest lecture.
but they have to go to the class.
Yes, sir.
जगह भी जा रहा सर ये
See outside, the boys can come. Oh, God, man, they make you the digital content and like
कैमरा बैटरी है निकाल के दे रहा नहीं एकदम चार्ज नहीं है मैं जस्ट फोटो निकाल के दे रहा हूं मैं दिख रहा है एक ही ठीक है इस तरफ
Go outside, see, let them quickly come in now because he's will be getting late for his flight.
अरे नहीं सर इतना नहीं विशाल
Let him make it. See that this be making it you or something. Some good suggestions. It's like what? We have to see that we are recording. Create our own YouTube channel.
That is killing the if you come forward, no? Easy वाले यहाँ बैठे हैं यहाँ पे
Good morning, sir. अरे सर ये क्या क्या वो तो होगा तेरा
Hey, come front, there's a space, no, come.
How to achieve, oh, sorry, how to achieve what we call UNSDG. That is, how many of you know what is United Nations? You know that? How many of you know about UNSDG? Anybody else? Yeah, please raise your hand. If you don't know, I'll explain. That's the reason. It's very important. Okay. United Nations has 17 goals that every village has to reach. All right. So how do I make that happen? Okay. So I'll explain that a little bit. And how do I use technology to make this happen? So this is the whole idea of talking about this particular session. Now, I'm sure many of you, how many of you are from a village? Oh, quite a lot. How many of you have ever gone to a gram panchayat? Okay. You are from where? Manipur? They have gram panchayat in Manipur?
Yes.
They do? Okay. I thought the northeast states do not have gram panchayat. They have tribal stuff. There are gram panchayats here? Oh, good. Then we will make her the champion for Manipur. So great, very good. The reason I am bringing it up, because many of us, because I did not know what a gram panchayat was, believe it or not. 2010, I came to know what a gram panchayat is. Okay? Because most of us in the city, we have no clue what happens in a village, what are the sufferings of a village, etc., etc. So we actually went to a gram panchayat and understood how people interact, because that is the place where people get all their services, because that's the local government. So we have 240,000 gram panchayats in India. Okay, just so that you know. And each of them is a government. Very important for you to understand. Each of them is a government. Each of them has elected representatives. Each of them have a budget. Just like Indian government has a budget, Manipur government has a budget, a gram panchayat has a budget. So they should know how to spend that money. Okay, so there are about 38 lakh elected representatives, and approximately they serve about 800 million rural citizens, and they also have about 30 lakh functionaries, that means what they call secretaries, etc., who are like the bureaucrats. So unless we train these elected representatives and these bureaucrats how to use technology, obviously they cannot provide service easily. Okay. So this is the reason we went and did all this. So these are the 17 sustainable development goals. Okay, one is obviously no poverty, zero hunger, good health, quality education, gender equality. All these things had to be achieved by 2030. That means in the next 5 years. It started almost 10 years ago. So every village in our country should have zero poverty, zero hunger, 100% education, and so on and so forth. How do we achieve that? It cannot be achieved the old-fashioned way. And that's the reason we bring technology. And each of these 17 Sustainable Development Goals, they have what we call 169 targets. For example, if I talk about good education, that means in a school, the girls must have a toilet with water. That's a target. So like that, we have 169 targets. Okay, I will just give you one example of a target. Okay, so this is how we look at how do we achieve these 17 goals. So each of them needs some kind of monitoring. How do I know that school has a toilet and that school has a water and that actually is being used by girls? Correct. How do I bring technology to it? Similarly, how do I make sure that an 80-year-old woman gets ration at her doorstep so that she doesn't go hungry? Because she cannot walk to a ration shop and get rice. Okay? So how do I deliver rice at her doorstep? How do I use technology? You got it now? So this is zero hunger, fantastic education. So we look at all these targets and look at how we use technology to achieve this. So this is the purpose of my talk today. And I will talk to you how do we develop, how do we do the what we call business process analysis, how do we develop apps, how do we teach them, and so on. And you can stop me in between if you have any questions, so that it may not be one-way traffic. So this is the Sustainable Development Goals in Gram Panchayat. That's the future we want. As you can see, that is United Nations, that's India. Okay, and this is a long time ago, Prime Minister Modi's what do you call it, vision also. How do we make every state, whether it is Manipur or Karnataka, how do we make sure that the state actually do this? Okay. See, with any government, obviously it depends on how people understand how a Gram Panchayat operates and what are UN SDGs. For example, how many of you knew what UN SDG was? Please raise your hand. About 5 or 10 people, right? Out of 150. Do you think if I go to a village and ask the same question, they will not come? If you don't know what UN SDG is and you have to achieve it, impossible. Okay? So the whole idea is how do you teach them what UN SDG is? How do you make them understand? How do you make them understand the target? So that means they should know what the functions of a Gram Panchayat is and what are the sustainable development goals. Okay, so we developed a technology called navigated learning technology. Okay, I'll talk to you about that. And many of the villagers who get elected or who are villagers, they do not know how to read and write. So we developed natural language process where they can ask a question in Kannada, Telugu, or whatever the language is, and they should be able to get the answer. Okay, and then of course, workflow automation. That is, how many of you have used Flipkart or Amazon? I'm sure all of you, right? Correct? That means, or how many of you have booked IRCTC train ticket? All of us. Correct? So what happens? If I want a shampoo, I go to Amazon, say shampoo, it gets delivered. Correct? The workflow happens. Correct? It knows who should pack, who should deliver, and what time it will come. The whole thing happens. That's called workflow automation. So imagine in a Gram Panchayat, I'm sitting at home, and I say, please give me my agricultural certificate. It should go and come to my desk. Okay, so this is what we call workflow automation. So that means we have to automate everything in the Gram Panchayat. Okay, so we look at these kinds of automation technologies called Gram Panchayat or villages. Because each Gram Panchayat has anywhere between 3 to 5 villages, and we want to make sure that everybody is digitally competent to make sure use these services of the government. So these are the kinds of things we have done. So that gives you an idea how we use technology. Today, when somebody has to learn something, they go sit in class for 3 days. They are all shipped in a bus, they go sit in a class, they get books. You know, even we don't study books anymore. We all watch YouTube. Okay? So people in the village are not interested in reading books. and learning. And they have to learn multiple domains. Okay? So we develop the technology where they can learn anything, anytime, anywhere. So this is called navigator learning technology. So we work with a organization called Guru in America, and this is called GPS for learning. You know, all of us use GPS, correct? That means if I want to come to IIT, my location is the airport, the route is one way. If my location is some temple or that market that I went to, Amma market, right? So the destination is IIT, but the route is different from the market. The route is different from airport. The route is different from somewhere else. But the destination is the same, but the location that I start is different. Okay. So similarly, what we have looked at is in a villager, he could be a primary school educated, she could be high school, and he could be a graduate. And you don't know what a 73rd Amendment is, she doesn't know, and he also doesn't. So the route which will I teach a primary educated person to know what a 73rd Amendment is different. For her it is different, for him it is different. Okay, so this is how we look at GPS for learning. Depending on the location of the student, we teach them differently. Okay, so this is the technology we have developed for implementation, so that they can learn any idea using our technology, and we can monitor how nicely they have learned. They need hand holding. For example, in GPS, if you lose the way, it reroutes you. Correct? It gives you a different route. So we have a technology where it reroutes and comes back and says this is the wrong way, come this way. Okay? So this is the kind of technology we have done. And we have, of course, there are multiple domains they have to learn. Circuit development, functions, WhatsApp, Grasshopper, JPDP. So they have to learn approximately 250 lessons, competencies, and approximately 750 micro competencies. Okay? So we have broken down all the things they have to learn and created very, very interactive, nice animations, videos, so that they know how to learn it rather than reading a book. So that's how we see the current methodology. If somebody is illiterate, they stay right there. And somebody who is educated reaches very high. Whereas in our technology, everybody reaches the same height. And this is called inclusive transformation. So that means it doesn't matter whether you are primary school or high school or college, everybody will learn accordingly based on technology we have developed. So how do we ensure this technology? So every level representative has a login. So they're very easily, they can log in and they use it. Of course, this is all done in Kannada because I'm from Karnataka. This can be done in multiple languages. It really doesn't matter. So they use a username and password and they can see what is their efficiency. They have learned 53%, they have spent 10 hours, their progress is about 13%. And that's the name of the lady who logged in as a student, who was a Gram Panchayat member. Similarly, you can see different subjects, how much she has scored in every subject. She knows she has done very badly here, so she has to be rerouted so that she can learn better. Okay, and how much time they have spent? 2 minutes on this, 1 minute, 1 hour on this topic, 7 minutes on topic, 34 seconds on this topic. So we know exactly how easy it was for them to learn or how difficult it was to learn. That means our teaching methodology could also be wrong. Therefore, we look at this. It's got 360-degree learning capability. So we look at that one. And of course, they take a test anywhere, anytime, and we score them. And then there are varieties of tests that are taken. And the beauty is, they don't have to sit in a class. They can be sitting in their village. They can be a shepherd, or they could be doing some work in a store. It doesn't matter. They can do any of this work anytime. And we track them, and somebody has answered 13 questions in 49 seconds. So obviously, yes, congratulations. And we can track them. All the dark blue means they have completed all these competencies. Light blue means they are still working on it. Gray means they are not even started. So we actually know how many competencies they have started, how many they have completed, how many in progress, and so on and so forth. So it gives an idea of the learning mastery in each domain. And of course, just by learning on a mobile is not good enough. They have to do an activity. for everything, because only when you have the experience of doing something, you learn something. Okay, so in very micro competency, there is an activity that is assigned to them, and they have to upload that activity after they finish. For example, many of them don't know how to transfer money. How many of you know what is IMPS, NEFT, RTGS? All of you know?
Yes, sir.
Okay. Do you know what's the difference between IMPS, NEFT, and RTGS? Yeah?
IMPS is the online transaction where NFT we have to go visit the branch and the branch assistant will do it.
Oh, okay, very good. Speak. I'm very interested. Okay, IMPS is online.
Online, yes.
And what is this NEFT?
For an NFT we have to visit the branch.
Okay, and RTGS?
RTG is also same like NFT, but for the higher amount we do RTG.
Okay. And where did you run this?
You think, right?
I think so.
Good. I'm glad you answered it wrongly. Very good. The reason is, see, this is what we call micro competence. Please sit down. See, people should know what's the difference between IMPS, NEFT, and RTGS, or Google Pay, or Phone Pay, whatever the case may be. Correct? So, unless they know, I mean, you don't know. I'm just telling you, you don't have to visit a branch. In NEFT, there's a bank person that actually validates your account and then only it goes. Whereas in IMPS, you have limitation, it goes automatically. Anyway, what I'm trying to tell you is, it's very, very important that they have to go through this experience of doing one IMPS transaction, one NEFT transaction, one not NEFT transaction. This is the activity. So like that, we give them multiple activities. So that not only they learn, but they also execute or do an activity. So that then only they get a certificate. So that they know how to do digital banking, for example. Okay. So that's the reason. So we go through it step by step. We give them a step by step process how to go through this. Right? The whole idea is bring them all up to the same level of learning. Okay. So there are multiple activities we provide. How to do a Gram Sabha, how to do. If somebody applies for an RTI, you know what an RTI is? So, how do I respond to an RTI? So all this they have to learn, and this is what we teach them. And this is the way we create. Just to give you an idea, this lady was a Gram Panchayat president. He's a technologist. He's a trainer. This guy is a street play guy. You know what a street play is? Because many villagers, they are not interested in watching a video. They want to see a 2-minute drama, 2-minute street play. So some of the ideas we explain through street play. So we create these 2-minute, 3-minute modules in order to make it interesting for them to learn. Okay? So that is, and this guy is a journalist. Sorry. This guy is a journalist and me. So we create these concepts in a very understandable way. Because otherwise villagers will lose interest very easily. So these are what we call learning technologies. Only by understanding this, then we create the app or the module so that they can actually practice. This is how we create the whole thing using the video. Then we go and spend half an hour in the village, train them how to do it. And once we do it, you can see all of them are using their mobile, learning whatever they want, anytime they want. So these are all the apps, advanced apps that we develop for villagers to use. Okay, and then we give them a certificate. So, and very important is, many of the people in the village are quite old, they don't even know how to download an app or how to operate an app. So we give jobs to youth in village. Youth, young people know how to download an app, how to monitor a video, how to run through a video, etc. So they handhold these old people old people or illiterate people, how to use apps, and we give them jobs in the village. So that way, the village people don't come to the city. So we give them technology-oriented jobs in the village. So not only do they help the villagers, but they also earn a living. So this is, for example, K.K. Swami was a mentor in one of the Gram Panchayats, and he has a class where he had about 14 or 15 people. And he can see out of 1,400 competencies, his class has learned 303 competencies. So we can give him a time frame. We have to finish all this in whatever, 2 months or 6 months. So he gets an idea
all these people, of course, these are all names in Canada, sorry. So this lady has finished, this lady. So you can say 14 people have scored 91%, 9 people have taken 95%, etc., etc. He can track everybody and how they have performed in that course. And this is again, number of domains completed, and he gets a bird's eye view. So this is the kind of technology we actually develop, that a village boy or a village youth can actually sit and watch and see who is doing very well and who is not doing very well. Okay, you can see here a complete view dashboard for him to see this. Of course, you can see individually this guy is a PhD in social science, Dr. Katalingaya. Okay, he's the president of the Gram Panchayat. He was the laziest of them all. Okay, I'm just saying it just because you have a PhD doesn't mean anything. Okay, so we were tracking him, how much he had done, how much he had done, how much he had not done. So then you can motivate him how to study. Okay, these are all the assessment. The good thing is you can see here. This is female non-school or male non-school, female primary school, male higher primary. So higher secondary, pre-university, graduation, doctorate. So we can actually track how people are performing in the village. Okay, so that we know if some people are having difficulty, some people are not following the modes of operation. We can track them and we orientate them according to how to make them achieve. There you can see there were 5 people who were non-school in that particular Gram Panchayat, 2 were primary school, and this guy had a PhD. These guys were graduates. So we can do, that's why I asked you, data analytics capability. So we get data like this large quantity, and we can do what we call predictive analytics. Those of you who are into data science, you can actually do predictive analytics. And I will show you how we do predictive analytics when we go to healthcare. So the beauty is, how do I use these technologies in order to bring transformation in the village? And we give this predictive analytics capability to the president of the Gram Panchayat. So he can see which people are bad, which people are good, or who needs help. Everything he is capable of seeing, and that is how we take technology. And this is our mission control. Let us say I am the Prime Minister or the Minister for Rural Development sitting in Delhi. I should be able to see how all these 240,000 Gram Panchayats are operating in India. Okay, that is the big vision. That's called the mission control. So I can sit in Delhi, and that is how we look at it. So at India level, okay, in Karnataka only, 1,361 competencies have been done. No, not in Manipur, not in Meghalaya, wherever. Okay. So that way, I know approximately 87.85% they are scored. On an average, they have spent 30 seconds. And in Karnataka, these are all the districts. We have only implemented in one district. So I know exactly which district it is happening, and not only just district, I know in that district, in which block or which taluk, and in which Gram Panchayat, these are the people. So it's possible for me sitting in Delhi to visualize every Gram Panchayat across my country using this vision control. I can see here Mr. Rajana has 11, and whereas Mr. Surama has finished only 1. So this kind of gives me a bird's eye view as to how things are happening across the country, and it will get. Of course, in data, and once you collect the data, you can do analytics in any which way and pull out data and make plans accordingly. Of course, you can do this in multiple languages. We are trying to do this in Hindi right now and in Telugu. And we have multiple levels: basic level, intermediate level, advanced level, and expert level. So that each of the course is triggered or managed for different levels of. And again, we are running in multiple districts. Just I won't go into detail. This is how we know exactly on the GIS map where we are executing all this. And as I said before, multiple levels. Very important, as I said, is how do I use NLP? Okay. So, how many of you have worked with NLP? Anybody? Oh, excellent. Okay. Are you teaching them already? That's the subject. I see. Okay. So we use for the almost 3 years ago, before ChatGPT and all came, because you know, those of you who know NLP, there is what we call intentionality. You have to create a huge LLM model, etc., etc. We did all this from the ground perspective, and so that click here to chat. So people can click here and ask questions in their language, and obviously it can be on multiple topics. So there's a text to speech technology, so they can hear it, they can ask the question in their voice, and videos, etc. will come. Because they cannot read, very important, they can only talk, they can hear a video. So we would put all these domains in as video, 2-minute, 5-minute video courses, so that they can actually learn everything using it. So this is how everybody who served this guy as a president, he was an engineer or a member, so they were excited to use these technologies in the village. So many people gave lots of certificates. Most important, this is called National Capacity Building Framework. So Government of India, Ministry of Panchayat Raj, recognized this technology, and in 2022 December, and they said this technology should be used in all the Gram Panchayats across India. Okay, so of course it takes a lot of time before governments take action. All right, so I just thought you should know. He was the secretary who agreed that this technology should be brought across India, and this is the certificate they gave how to use this kind of. This is a SaaS platform, SaaS software as a service platform, and we are still. So if anybody in Manipur is interested to take this technology, we'll be very happy to share the technology and take it across Manipur. So we have already done this. And very important, next is, once I learn how do I do workflow, as I said, Amazon, Flipkart is a workflow. So if you go to Gram Panchayat, you will see there are 130 processes, okay, which we did not know. So every process has to be automated. So we completely developed a workflow. Whether you are an elected president, or a member, or a secretary, or a citizen, you should all be able to work on your mobile and get all the service from the Gram Panchayat. Okay, so that you don't have to go stand in line, give a sheet, it says come back after 3 days. All those things are solved. So this is the technology we developed, where people can log in with their username and password, and these are all the different apps they could open. I want to check my property, whether I have taken my trade license, or I want to advertise in the village, anything. So all these things are possible using the dashboard that citizen or. And the beauty is everything has a what we call a timestamp. So you know exactly what time somebody did the job. So you can do a performance analysis whether he was doing a job, etc., etc. And I wrote a book on this. It's called in Kannada. It's called 21st Century Atmanirbhar Gram Panchayat. Okay. I did the whole thing in English. Okay. But as soon as I put Atmanirbhar, they thought I was a BJP guy. So sorry. So then I had to change the title in English. So it's about a 600-page book on how to use these technologies. We use blockchain, AI, natural language processing, navigator, workflow, IoT device, theory of change. How many of you know what is Six Sigma? Anybody? Yeah, you know Six Sigma. Any of the students know Six Sigma? Okay. This is the next thing that we have to look at. That means, how do I make zero defect in any process in the government or anywhere for that matter? So this is the way we look at a defect-free process in every government department, and that's called the Six Sigma process. So we are trying to bring Six Sigma process and also look at what we call a new technology called community network technology.
where internet can be there for every village house. Now, because you cannot build an optical fiber to every house. Okay, so these are all the technologies that we bring. So that is why applying frontier technologies for capacity building. Oh, sorry. We won a big award from Bihar Innovation for this kind of technology development so that we can implement it across the country. I was actually invited by Afghanistan. The only guy to get invited by Afghanistan to implement this technology in Afghanistan. Okay, but other than me, nobody else wanted to go because they were all afraid to go to Afghanistan. Okay, so anyway, so it's very interesting that Afghanistan is interested in bringing these kinds of technology for their local government. So I just thought it's possible to, once you develop a technology, you can really take it across anywhere. This is very interesting. We also work with tribals. See, I'm sure Northeast has a lot of tribals, correct? And the tribals, they speak and everybody, only the other tribal guy will understand. And interesting thing is, they have no script, correct? Whereas Bengali, Assamese, Kannada has script. They have no script. So they have to use either an English script or a Devanagari script. I don't know. Many of them, they don't even use that. It's only talking. Okay. So we are working with IIT Harvard and IIT Harvard to develop speech-to-speech technology. Okay. So we work with tribals in Karnataka, Soliga tribes, and so these are some of the professors from IIT. There are some Soliga boys here. Okay. So the whole idea is, those of you who are tribal people, you know, we have to develop a large language model for the tribal language. So you're from Manipur, right? Correct. Is there any other Manipuri or any other tribal people? Please raise your hand. Very few. Correct. So if I am a tribal and I don't know, I have explained to the doctor I got stomachache, I can only speak in my language. That guy doesn't, the doctor may not know his language, that language. So this technology we have developed is, I can speak in whatever, Solika or Manipuri, he hears it in English, and he answers back in English, and I hear it in my tribal language. Okay, so this is speech-to-speech technology that has been developed with Mahadev Prasanna. Yesterday you sent a note to him. So I worked with Mahadev Prasanna, IIT Harvard and IIT Harvard, and we worked with the Solika tribes. And the beauty is, we have to create a law. How many of you know what is LLM? All of you know? Yes? Raise your hand, all of you. Yes? What is LLM?
Large language models.
What does it mean? Go ahead. Okay. See, very important is, when, of course, in English, you use ChatGPT, there's a LLM. In, I'm sure Bengali, we have a reasonably big. Hindi, obviously, bigger than Bengali. Okay. In tribal, we have to actually create an LLM. Okay. So that means in multiple domains, it could be food domain, marriage domain, house domain, youth domain, old age domain, like that. So we have to bring varieties of people in the tribal community to make them the same subject, everybody expresses it differently. So we have to bring varieties of people and create a large language model for the Soliga tribes. So there are 600 tribal languages in our country. So we have to seriously look at how do we create LLM, so that otherwise the tribal culture will go away, the tribal language will go away. So that is the whole idea. So we are working with this kind of technology for rural tribal population. The other thing we did during COVID time was people could not walk all the way to a ration shop, and they had to put a thumbprint in order to collect their 5 kilo or 10 kilo rice. Okay, many people could not go, and many times this thumbprint did not work, so they did not get the rice. So we developed a face recognition technology, so that if I hold a, this is, of course, everything is in Kannada. So
This guy is Gangama, Krishnappa, Ramegowda, these are the people in the family. They just have to show their faces. Then they will say, automatically recognizes this is Nanjappa and he has to get 10 kilo of rice. The message goes to the ration shop and automatically he sends 10 kilo to the doorstep. And then all I have to do is once I have received it, I have to do a gesture recognition that I received it, the loop is closed. Okay, so that way we could deliver rice to the doorstep of old people, except people who could not go, etc., etc. So these are some of the technologies that we developed. Okay, so it could be delivered right at the doorstep. This is the latest technology we developed. It's called Primary Healthcare or Technology Network. I don't know how many of you have ever entered a primary healthcare unit. Anybody? You have got your PhD? Is the PhD good? Was the doctor there? Correct. So many of us have never probably come to a PhD. Okay, villages, we have, just so that you know, we have 1,80,000 primary healthcare centers in India. Okay, and that is where most of the villagers go for their whatever, OPD, etc., etc. So we got a huge grant to develop. This is the kind of technology we develop. I don't know how many of you have Ayushman Bharat card? How many of you have Aadhaar card? How many of you? Correct. Every one of you have Aadhaar card. How many of you have Ayushman Bharat card? See, none of you have Ayushman Bharat card. You see? Only five. Somebody raised. You have? Okay. Alright. So this is an important health ID that every Indian citizen should have. Just like Aadhaar. Okay. So the beauty of this is, with that Ayushman Bharat ID, all our health details will be on our mobile. And I can share it anywhere I want using what do you call consent. That means I can come to Manipur. If I see a doctor tomorrow, I don't have to carry my folder. I just say, okay, here is my thing. He can see, okay, I got diabetes, I got mental problem, whatever the case may be. He can see. Okay, so that way he can prescribe what I want. So this is the architecture of Ayushman Bharat today. So we took that, and you can see here. So every citizen has a health ID, and in our country, every village has a village ID, and we also found out every household in the village has a household ID. So with this kind of identity, so we could create a huge data structure. Okay. So when I create a huge data structure, I collect data at different levels. Citizen data, ASHA worker data, village level, household level, individual data, okay, and primary healthcare officer or nurse data, and health worker, eligible count also, it's called RMNCHA, maternity mortality rate and infant mortality rate is very high in our country. We want to bring it down to zero. So we have to understand how people are having children, how they are taking care of nutrition, etc. So these are all antenatal care, postnatal care. How many people have communicable disease like tuberculosis, COVID, malaria? How many have non-communicable disease like diabetes, hypertension, cancer? This is village health and sanitation committee, personal health record, identity management through facial recognition. Please, when you walk into a primary healthcare center, it automatically recognizes you and says, "Good morning, Shankar Prasad, you are registered." So that when I walk to the doctor, he already has all my data right in front of him, so that he doesn't have to ask too many questions. Okay, so this is a technology we have brought into rural India. Okay, and then of course we have IoT device integration. Some very important is GIS mapping and predictive analytics, because we collect a lot of data. It is possible to predict what will happen in one village. Okay, next year I expect dengue in this village, or next year I will have a lot of diabetes in this village. So it's possible to predict like that. Then we have all the messaging system and so on. So I won't go into the detail, but what it does is you have developed 23 apps that are based on these IDs. And everybody who is using that app, there is integration of the data. Whether you are an ASHA worker or a citizen or a medical officer or an Anganwadi worker or a Gram Panchayat. So the beauty of this huge data lake, most of you know what the data lake is, I'm sure. Yeah. So the beauty of this data lake is I can write
algorithms and patterns to make prediction as to what will happen in that village. Varieties of data is collected. Of course, this is everybody has a username and a password. I will not go into detail. Okay. So these are the multi-level apps. So if I want to do village level, household level, eligible couple, antenatal care, postnatal care, or pulse polio, etc., depending on what I want to apply, I just use that app. Data is collected using these items. We actually collect in such a way, if there is a temple and the temple has a well, I should know whether the well has mosquito larva. Okay, this is the level at which data is collected and whether the ASHA worker has put the medicine or not, whether she has taken the water sample. So we know exactly how to track whether the ASHA worker has done her job or not. Because if she has not put the medicine for the larva, guaranteed that that village will have dengue or malaria next year. Okay. So we look at these kinds of data collection and data analytics based on our app data. And we, of course, we have everything is with lat long. So we know exactly what day, in which lat long, who did the process, and we can track at a higher. And this is the IoT device. If I am an ASHA worker, I can walk into a village and I see a patient, I apply this. So the doctor can see her blood pressure or his blood pressure, his ECG, his SpO2, his temperature, and then we have a video conference immediately and he can actually prescribe. Okay, so these are all this data is collected again in my data lake. Okay, so that way I got all this data where I can use that data for predicting what should happen in that particular village, whether I can have more oxygen cylinders sent to the village and so on and so on. So these are the kinds of stuff we have done. And as you can see here, I can know exactly which village there is diabetes, which village hypertension, which village has cancer, which village has anemia. Everything is possible for us to predict at a village level. And we have lots. Once you have data, you can provide this data to decision makers at the village level. That is the beauty. So that I know exactly who has a kitchen with no smoke, who has got water states with drinking water. All kinds of data can be given so that decision can be taken by either the Gram Panchayat executive or the district level officer, whosoever it can be. And that is the beauty of this. So you can see who has got waterborne diseases that I can predict. And here is an example. These are the 5 houses where I can find A negative blood. So in case of emergency, I know exactly where to send the ambulance. Okay. So that way, it is very easy for the villagers. Since many of you are software types, when you architect a solution like this, it has to be architected extremely nicely. So we look at it from an India level. Okay, so the architecture of the software is very crucial. So we look at it from country to state to district to taluk to Gram Panchayat to PHC to a sub-center to a village, etc., etc. So the architecture of the software has to be built because you cannot change the architecture later. Those of you who are into software, you know, it's an enterprise management system and it is mission critical. You cannot go and play with it anymore. It has to be very secure. Very important is this data has to be very secure. So we look at all these issues when we develop this kind of technology. Based on that, how many of you have anybody worked in companies like Infosys or Wipro or IBM? The reason I'm asking is, we have what we call, in a company, we have what we call capability maturity model. That means, so if I ask one of you, let me ask the blue shirt guy. Yeah, you're going to graduate, right? How many years? 2 more years?
Last year. I am first year.
Oh, you're first year. You've got 3 more years. Correct. If I ask you, would you like to work for Google?
Yes.
Or Infosys? Or Tata? Who do you want to work for?
Maybe Google.
Why?
They pay more.
Probably they know more. Correct. That means we have obviously, if I did not take Google name,
If I said Infosys and TCS, which one would you want to ask?
Infosys.
Correct. You see now, right? So we have a picture as to who is a better company. Correct? You understand now? Please see now. So this is called capability maturity model. So that means we know Google is better than Infosys, or Infosys is better than Tata, or Tata is better than Mahindra, whatever the case may be. Correct? You understand now? So we have enterprise maturity model. That means we all know this company is better than that company. Similarly, we are taking a Gram Panchayat maturity model. So among the 240,000 Gram Panchayats, I want to know which Gram Panchayat is the best in Karnataka, which is the best in Manipur. It is possible for us to create a capability maturity model. And this is a model that we are trying to create, where we have level 1, level 2, level 5, etc. Level 5 is the highest, and these are all the variables in which we collect the data, so that we can specify who is better. And very important is, whenever we talk about this technology, internet is very crucial. So not everybody can have optical fiber, and not everybody has geo, etc. easily. So we are looking at a technology called white space technology. I don't know how many of you have heard about it. You know? Yeah, you know white space technology. So we are trying to convince the government to bring white space technology into villages, so that they can have Wi-Fi high speed using the old technologies. So these are all the kinds of work that we do in order to bring digital transformation in the village. I thought I'll just give you an overall picture. Of course, now we're also looking at using blockchain. Okay, because every transaction has to be trusted. So if I sell land to somebody, that should not be modified in any way. It has to be trusted transaction. So we are looking at how we introduce blockchain technology for trusted transaction in the village. This is how we look at how people can participate. Okay, that's how we look at how do I bring local self-governance. These are all the roadmap that we think Indian government should follow in order to bring transformation across all the 240,000 Gram Panchayats, 6 lakh villages in India. Okay? It's a huge task, but one step at a time, we think we can achieve. Thank you very much for your patience.
Now, whosoever is curious can ask questions to me.
If you have anything to ask, you can ask freely. So I will be happy to answer you all.
Yeah. Was this all new to you, or was this over your head? Okay. Was it an interesting topic for you guys? No, not just to make me happy. So seriously, I'm asking you, does this kind of thing interest people who are in software or computer science? Any ladies can also get up. What is the feedback? They were very thrilled. They were very thrilled because earlier they could not get any information. Now the beauty is they can use their mobile to get all the information that's what's happening inside the government. They can see it on the computer. So they were very, very happy to see something happening like this. But the government elected representatives did not like it because all the citizens were getting all the information. Now everything was hidden inside in paper and pencil. Now everything is transparent. So two different approaches. Okay. All the bureaucrats did not like it. All the citizens liked it. So it's a very good question. Yeah.
Any more questions?
See, ML, AI, data, all those things, he has also given what are the various problems, right? And ultimately, all your AI and whatever you learn, that should give a solution to the common man, right? And therefore, these are the various areas you can think of and find some solutions. You can make money also, not necessarily like a service what is doing. A good example is Ola now. They just put all these things together and they have a data, and then now the vehicle is at your doorstep. That's what.
Sir, I have a question. Sir, without jumping to corporate jobs and all, I also want to work something for the society and for the common good. So how can I start in this journey?
Very good question. By the way, there are lots of opportunities for people to work in this domain. There are quite a few organizations that are into digital transformation. So you don't have to work for a corporate with a CTC of 60 lakhs. Okay. But you may not get 60 lakhs. You may get half that. But it's one good thing is it's very enjoyable because you're not sitting in a cubicle and working. You're actually interacting with people and you bring actual outcome at the people level.
You see, he worked for Intel and he also worked with the founders of Intel. And ultimately, that whatever you talk about your packages, all this he has seen. Now, you look at his age and where he sees the happiness. Where he sees the happiness? By doing service to the people. If you could transform few villages, that is where he gets more happiness than whatever your Google package or Amazon package. Ultimately, all of you are also going to come back like this. Okay? I think what the question asked there is very, very good. Yeah.
Sir, I have a very curious question. First one is it a profitable organization, sir? Some good service.
Oh, we don't look at it as profit. It's an NGO, it's a non-profit organization. So when we develop a technology like that, there is something called CSR, corporate social health. So we tell Tata Trust or the Infosys people, etc. Look, this is what we want to do. How can you support? So we take grants and then support. But we had about 35 people to develop that primary healthcare technology. I had 35 people work on this. Okay, from solution architects to UI UX designers, everybody, all high-end technology. So they all got paid because we got about 3 crores as the grant. So we paid them. So we look at it that way. So eventually, we are going to open source this, by the way. It's already, we are planning to open source it so that anybody can take it. So we are not looking at it as a profitable entity because social service, according to me, cannot be a profitable thing. There are social entrepreneurship models. We still have to think about the way that's possible.
Another curiosity is that in the software architecture, so whatever the key inputs or key findings you are going to get it, so that model is now once you see it from the screen, is visible. But before that, it was not visible. So those critical points were set by government like a policy or you inherited those points.
See, I've been working with this kind of enterprise architecture for quite some time. But we have to study the architecture of India is President is the owner of India, meaning he is the first citizen. Then everything comes down to central government, etc., etc., etc. So if you understand the governance architecture, then that is the spinal cord of the architecture. Then of course, money architecture. Okay. So if we integrate the governance architecture and the money architecture, then everything falls into place. But you have to study that. Yeah, you have to study that and then it gets approved by the government. That's not.
Thank you.
Yeah, anyone last question? Yes.
Yes.
Sir,
much mobile users, but towers are so come. So how can we overcome this problem?
Good question. There are two solutions we are working at. One is called the white space technology. Okay. I'm sure he knows more, he can explain. But the beauty of that technology is, you remember 20 years ago, hello, ladies and gentlemen.
Hey, listen.
One more minute, one more. Yeah. 20 years ago, we did not have dish TV, correct? We did not have satellite TV. All of our houses used to have that aeroplane-looking antenna. I'm sure all of us know, right? That frequency today is not used. All right. But that frequency can transport almost about 8 kilometers of Wi-Fi data without any attenuation. Okay. And this is called the white space frequency. So if I have a Gram Panchayat office, I can just go back and show it to you since you asked the question. Slides. You see, this is the Gram Panchayat office, and I have a transmitter there. So today, every Gram Panchayat has an optical fiber. That means the internet comes there. All right. So on top of that, I put a transmitter like that. Then any house in the 8-kilometer radius can have Wi-Fi internet without putting an optical fiber. Okay. So and they will have small receivers there. That's all. And it uses the old-fashioned the antenna. Okay. And that's very cheap. So this is a technology that we are trying to convince the government to implement. Because you cannot, in the hilly regions, you cannot pull optical fiber easily. Okay, unless of course Elon Musk comes in with his satellite, whatever, link or something like that. But at the end of the day, this is a technology that is possible. And we are also working with another technology called community network technology. Okay, so these are the technologies that we think is very useful for small villages, in tribal villages, in hilly areas and so on. Yeah, but otherwise, all this technology has no value if there is no internet. Right? So this is what we are doing.
Maybe one last question, yes, sir, that boy wanted to ask.
So, you told that we have to digitalize our Gram Panchayat and we can transfer our land through digitalization or something like that, and we have to give our other details. We have to enter our other details through digitally and phone numbers. If there is any technical glitch, our details, the citizen, the details of every citizen will be in the hands of the hacker. So how can we, what is the solution for it?
Yeah, first thing you have to understand is there is a technology called blockchain. I don't have, is anybody teaching blockchain here? Sorry? I see. So that is the future where when you learn blockchain technology and when we implement blockchain technology, there is tremendous security. Okay, there is hash for every transaction that happens. Once, who is going to teach blockchain? You going to teach? You don't. I say somebody has to teach that technology because that is the future of data integrity. Because it's not just health data. Every data, whether your Aadhaar data, your bank data, every transaction has to be blockchain. Okay, and that is actually coming up, particularly in land area, because land is the fundamental possession of every villager. All right, and you can see there's a lot of gold mine in land. So many governments are working on it. Someday it will happen. But you could be the first guy to become a blockchain expert from IIIT.
Yeah, maybe one more last.
Sir, as you said, this is a very wonderful idea and initiative to connect villages and gram panchayats like that. Sir, but one problem is there with students. We parallelly, if you want to engage with this NGO, parallelly we have to take care of our means family. Financially we have to take care. We have to earn a livelihood for our family. So how can we manage that parallelly? Means if I am connected to with your NGO, uh, I have to manage my other priorities also. So how can we achieve that? Practically feasible. Means how can it practically feasible? That's my question.
Okay, good question. Let me ask you, are you in fourth year or second year? Which year are you? Second year. Second year. So you got 2 more years before you graduate. What is the CTC you want?
Minimum 25.
Are you speaking for him or let him answer the question? I'm sorry?
Minimum 25.
Oh, you got down to 25. Correct. So that means it all depends on what your CTC requirement is. Correct. Okay. Now, when you have 25, you are going to buy a car, let's say Honda, Accord or something. Correct. If I tell you, hey, Maruti is good enough instead of Honda, would you be happy?
But
Maybe.
I didn't get it.
Okay, I didn't get it. So the whole idea is the you bring two to three different things bring joy. Very important to understand. Okay. One is of course big house, big car, beautiful girlfriends. Correct. All these things bring you a lot of joy. No doubt at all. Correct. Okay. So now the question is, you have to decide: is it better to have all this, or is it better to do something that brings joy internally? Okay, so these are the questions that one has to ask themselves. Okay, because in an NGO, for example, you will never get a 25 or a 35 or a 60 lakh CTC easily. All right. Therefore, it's a decision that one has to make. However, I know people who have worked with me who work for Google and IBM. Okay, for 10 to 20% of their time, they come and work with me, and they don't even take any money. You see now? So, because that kind of architects, I could not find anywhere else. Because he's an IBM architect. Okay? So, very easy for me to ask him, please come in. I cannot pay you 1 crore or whatever you get. But he was very happy to come and work because he would never had that experience of working in a primary healthcare center in his whole life. You understand? When he actually goes to the village and works with those ASHA workers, sees those people use his app and smile, no IBM, no Google can provide you that smile. You see now? So these are options that one has to decide. And you will see when you get to the good.
Okay, sir. Thank you very much for the excellent thing because we are running short of time. What, Naveen, you want to ask something?
Namaskar, sir.
You can ask in Kannada also.
Oh, and that's why I said, the way he said it, it must be.
Sir, nandu Yadgir, sir. Sir, around 30% of the, some studies show that around 30% of the GDP, the amount of 30% of the GDP, it's in black money.
Yes.
It's in black money. Some studies suggest this thing. I googled it. So I found out that if we implement this app, how much the peoples are going to accept this technology? Because those who are going to involve in these things, most of them they will be illiterate or literate. They are dependent on the personal perspectives. But how many people are going to accept this technology?
Good question. Okay. All of you use either Google Pay or Phone Pay? Correct? Earlier we all used to use cash, and you would say, oh, don't pay GST, and don't give me bill. Correct? We used to say that, right? I mean, a lot of us. Correct? So that is the source of black money. When I pay cash, and there is no accountability. As soon as you pay through Google Pay, Phone Pay, Paytm, or bank transaction, that means it's already it's tax. Or at least people know, if I spend 1 lakh rupee on dinner, people know where the hell did Shankar Prasad get 1 lakh rupee. correct? To buy a ticket, to the air ticket, or the dinner ticket. So the whole idea is digital transformation will bring automatically transparency. Okay, so that means people have to think that they want transparency. So it's a cultural change that people have to have, it has to happen. I think most of the young people today, because you are already digitally transformed, corruption will automatically come down. Once I make all the systems in a gram panchayat or in a government digital, that becomes the whole idea for us is how do I present this data to the citizens? Okay. For example, if I ask you, what's the budget of Manipur government? Do you know? I'm sure none of you know what is the budget. How much did the chief minister spend on his trip to, I don't know, Tokyo? Do you know? You have no idea. Correct. That means there is no transparency in government. Now imagine, this is what we are trying to do. Bring transparency in government. That means if the chief minister went somewhere, hiring a private plane, citizens should know. Did he take his wife and children, or did he go alone? Did he work, or did he stay on a beach resort? People should know. Okay, this is the way we look at it. So we are starting from Gram Panchayat level, and then go to the higher and higher and higher level. As soon as that's what we call participatory democracy. When I elect somebody, when I elect you, I expect that you are working for me, not stealing my tax money. That's correct. That is the way we look at governance. That's what democracy is all about. So this is slow transformation. So with people like you trying to bring digital transformation in governance, that will be the ultimate achievement. Because if you go to Estonia, etc., I have been to Estonia and Japan, perfect. Everything is digitally transformed. Okay. So this is the way I think India should be. We have the capacity, we just need the will and the intention to make it happen.
Thank you, sir.
Thank you.
Yeah, I think when computers came in, also the same problem, and then when digitally it was still in Manipur, when you go to the market, they'll still ask money or cash, or when you go to Emma market, they don't ask you to pay GPay, because that's the mindset. I think it will transform, but Estonia is a small country, it may be easy to transform. I was also there in Estonia. But 1.5 billion people, no, it will take time. Not only that, we are democratic, right? Democratic transformation will take much longer time, like our communist neighbor. No, you cannot dictate people. They have to slowly have to. Yeah, and definitely we have been changing and we changed, right? I think yeah, we had enough discussions, and we are extremely thankful to you for your wonderful lecture on semiconductors, PAP, and the future technologies, and also ultimately whatever technology you ended up with, that it has to reach a common man who is in the villages. And let us give him a very big hand. Thank you very much. We look forward to see you again and again. Thank you.
Thank you.